Audio test 1, 2, 3. Sounds good to me. Okay, so if I've got everything lined up the way it should be, we should be recording. Everything is up and running. And I think that means that I am ready to, that's interesting. Ready to get started. Okay. All right, sorry, just checking through all the settings and so forth. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. We are building a game with no game engine and minimal dependencies. We can lay them out basically as 4 or 5, depending on how you count it. Very minimal dependencies. We build every other system ourselves, other than rendering, window handling, the text, font rendering, and the sound. Those are the 4 things we allowed ourselves. And that's it. And GeoMath, I guess. And I think we can get rid of 1 or 2 of those next game. But that's where we're at. So yesterday we used aim. We finished up those animations. We lowered the bow. We then worked on arrow flight physics, and it looks pretty good. The arrow does stick in the chalkboard edges, so that's nice. You do have an arrow inventory with indicator. You can right-click arrows to retrieve them. And Robin Hood can indeed shoot himself. We set the maximum angle, so if you set the power right, it goes up to the top of the board and it gives you just enough time walking forward to get underneath that arrow. After that, I did get some new pen art this morning, and I was looking for new words and quotes for the doodad of the day. But we're just grinding through some of these items. So today we still have some Robin things. I added some notes after stream. I kind of want a Robin to be able to die. I think it's a funny Easter egg. So we'll implement that today. And then there's 3 or 4 sounds. I do kind of want a target and a score. I think that could be fun, because then there would be like a maximum score, and that could be like an achievement, even though we don't support Steam achievements. If you land all 6 arrows in the target perfectly, then you're good to go. Other idle animations. Wave, yeah, and then a couple of idle animations to do. So yeah, there we go. The trickiest part, I think, is when Robin dies, how do I keep the arrow attached to the head through the animation? Because the head will move throughout the animation. I'm going to keep the arrow relative to the position on the head. I don't know how I want to do that. Or when the arrow hits Yeah, I'm not sure how I want to do this. This is what we got on our plate today. We'll try to finish out our little archer dude. One thing I want to do, and this is a small task, rename Robin to Robert. Robert of Locksley. So let's get into it. Archer. Robin to Robert. Robert of Locksley. We could also go with William. For William Tell. That's another great archery legend. Robert of Locksley. Okay, so there's that. So we need okay. Okay, so there we go. Now we need him to die. Dying. It's 9. Dead equals 10. Dying is not going to be. Let's see what we can do on the animation front. Let's go to do. Yep. So I guess I need to turn the GIMP on. Okay. So the short answer is we need a new layer group called dying. We're going to steal idle these two. So we're going to duplicate, move that down to dying, and the bow. Okay. And then we move those two pieces. So if you get shot, we're going to start this animation. Somebody said we should make him dab, so that's fine. I approve of that. I think it's hilarious. So this is dying 1. Or just dying. Okay. We'll add some more. Oops, not that one. This one. Okay. Just want to drop. The only way for the arrow to really hit is at the top of the head. Very, very well. Okay, we need to trim some pixels off the bottom of this so it can keep lining up. 573 to 579 layer. Chop 7. So 57. Wrong. Hmm. There we go. Okay. Duplicate. Duplicate. All right, the bow is going to fall some more. Right about there. I think like a 6 or 8 frame animation for dropping the bow. Did not resize this one. Seven, 3, 4. Okay, so in this case, the arrow is going to hit and rotate like it's bouncing. It is 9.5 to 9.2. One, two, three. Then we need to lose some pixels off the bottom here. So we need to go from 573 to 86. That's 13. 13 puts me at 61. There we go. Okay. Now, duplicate. Duplicate, yes, animation is an interesting little process. I've been mixed parts enjoying and not enjoying it. I like the result, but the amount of time it takes to animate things is a little bit not shocking to me. I know it would take a while, but that's different from actually experiencing it, I think. Okay, so we're going to continue the rotation. It's an experiential thing, I think. And we'll rotate about there. Okay, I think a couple more. Now this guy needs to move over 1 pixel. So 64. Nope. And we're going to make it 1 wider. And then 1 smaller, which is a little bit of a silly game to play, but you know, we work with the tools we have. So 573 to 70 minus 6. So 75, resize, okay, trimmed. So where are we at? 1, 2, 3, 4, 5 frames. We've got 2 or 3 more in. I'm gonna let the bow drop. I will say, I think we're getting faster at all this. Hey, G Finelli. How am I doing? I'm doing good. I'm doing good. We're animating death right now. How are you doing? We made it so the bow can shoot up and you can walk forward and the arrow can shoot yourself. So we're going to try and implement that today. Stick figure death. So he's dropping the bow. It's going to be great. It probably means this is no longer a violence-free game, but that's fine because sometimes violence is funny. Okay, we're going to move the bow down. Yeah, about there. One, two, three. That's right. 6, 7, 8. So maybe we'll do an 8-frame bow drop. Hey, Upsy Kangaroo. Good morning. Good morning. Doing good. I changed the storage I was using. Things worked out. Nice, nice. That was your allocator bug yesterday. Upsy Kangaroo. We're implementing death. We are implementing death. We gotta have a little animation for it. So that's gonna be amusing, I think. Six. Seven. We might take some other aspects of the I don't know. We're gonna play around with it a little bit. Okay, the bow. Duplicate, move. So this is bow 6. Let me check that. Okay, not for me. I'm gonna make the bow fall all the way to the ground here. There we go. And then these last 3, the bow is gonna like fall down to the ground. So we're gonna go to 6. Paintbrush grunge, 8 pixels. The bow was done in 4 pixels. And our color, oh, I hate it when tool options gets. There we go. We want our brown back. Bow number 6. Just gonna sort of fall over here. I guess we just kind of, come on. That's not what I told it to do. Wow, okay, this is stupid. What on earth? There we go. There's my tool settings. Yeesh. Just ignore the bow. Paintbrush, grunge. 4. Now the bow is just basically gonna lie flat on the ground. To move. Okay, so there's part 1 of the animation. I kind of want there to be like a breathe cycle through here. So here's the 1, 2, 3, 4, 5, 6, 7, 8. And the drop is 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's fine. I think we'll actually steal the characters out of idle and replace all of these guys. Allocator in the storage for components. Yep. Before I had a sparse set, now I'm only using a dense one. Next step is asset loading, caching, and buffer allocation. Very good, very good. Chief vanilla, you're following an ECS style for components. Yep, it is fun, just really hard for me as the first time making a game and doing all from scratch. Simple ECS. Yep, I was about to roll my own, but I got lazy and used end. For sure, mine is nowhere near good enough. Yep, but mostly for learning as a whole. Correct. Correct. If you're not doing things and making mistakes, you're not learning. There's a good quote from Ed Catmull about that. Dense set like mine is horrible in the long run, but it's for a small game, it's fine. Exactly. You add complexity when you need it. Nice. Feel like since you know how your data is stored, you can really optimize your game. Yep. Exactly. You have more control and will have more knowledge if you do it yourself. Not always strictly necessary, but I think it's an important part of learning, right? I mean, until you build a big complex system yourself, you're not really learning. So we want that breathe cycle. All right, duplicate. Duplicate. Because one of the big problems with a game engine is they make assumptions about how you'll use their pieces, and it's never almost right. They're trying to appeal to the lowest common denominator, which means that the optimizations they can apply are minimal because they have the least knowledge of your system. The first step of optimization is to exploit everything you know about your system and its usage. So, kind of yes, but not that much, so it will have memory overhead for things that it doesn't need to because it is dense. Yeah. But modern CPU for small games, or modern memory for small games, I would not worry too much about RAM until you start running out of it. So any entity has all components at a null state unless added. Yeah, yeah. Well, as long as it's a pointer to a component, it's only the size of a pointer, right? For each entity, that's not that big. The fixed use a sparse set and a dense, so sparse would be empty, but dense would be really small and good. Makes iteration a nightmare. Yes, iteration. Always fun. Always fun. All right, 3, 4, 5, 6, 7. Always trade-offs. Okay, so dying 3. Dying 4. Dying 5. Dying 6. And dying 7. Okay. So 1, 2. I'm going to let him have one last breath. And breathe cycle in here. While the bow falls. Is Wilhelm Scream, is that public domain? Gosh, I hope so. So I think that might be the way I go. So we're going to delete these blank ones. Okay, next up is the dab. So from this position, so dying 8 is the start of the dab. Okay, we need the dab. Dab-a-dab. Let's see here. The real fix. All ECUs do is archetypical ECS. I could see setting that up. Where's my off by 1 error? Yep. It's not the case with some filters. I can't wait to see the death animation. Yep, the dab's coming. Maybe it could dab based on the direction of the arrow. We're going to stick with a simple dab on one side to start with, I think. Asset loading the renderer storage is what is being the hardest part. Asset loading and storage, yep. Which, if you really think about programming, 99% of it is moving memory from one location to another. And that's exactly what you just said. Asset loading and render storage. How do you get the data you need, where you need it? Okay, so let's get the dab going here. To start a dab, the first thing you do is you erase everything but the hands. So I want actually a black backdrop so I can do this properly. And whoa, 4. There we go. Because when you animate, the easiest thing I've found is to put the end effectors where they belong. Okay, now we're going to duplicate this guy. What do you think? 6 or 8 of them? Six frames for the dab, maybe? We're just going to draw his hands moving in different places. Then we'll fill in the arms. That's easier that way. Yeah, if I'm feeling like it, we could easily make the bow drop one animation, which would then automatically feed into the next state, which is the dab, which we could then pick a left and a right dab. So the way we're doing this doesn't preclude the left dab, right dab. Or we could, I mean, we could dab both sides. Yeah. There are options. 11. Never mind, this one is 9. 11. 12. And these are all misnumbered now. Perfect. 10. So it's here 9, 10, 11, 12, 13. So this is actually 13. 12, 11, 10. Okay. I think we need 2 more. I don't want to rush the dab. So that's 14. And 15. We're in no hurry. Nothing is fast once you're dying. That's the rule. 13, 14, 15. We got them backwards somehow. Luckily, that's easy to fix. 14, 15. Okay, so there's our dabs starting. 9, 10. Here we are. Okay. So we're going to get our eraser. We're going to erase the hands. No. I don't want the paintbrush first. We want to. So let's see here. One hand is going to follow this arc. The other hand is going to basically go straight up. So then this one and we'll go right about there. Up there. About there. Dab. Then 15. That looks a little high to me. Okay, so there's the hands. Now I've got to erase the old hands. Which just gets easier the further along the animation we go. Oops. Okay. All right. 9, back to our paintbrush, grunge, 4. Elbow. Elbow comes out a little further. There we go. this bad boy. Elbow. I suppose I need to start like a head drop somewhere in here so that the head lowers. Right, that's a part of a dab. This paint. It's 8, isn't it? That's what we should have done. Skip one we did. Right, I actually don't like most of these arms. We're gonna undo a lot of this work here. We're using that 4 pixels, which we used for the bow. And we should have been using 8 pixels. Let's start over real quick here. This isn't too hard. Okay. Thicker arms. Our archer is no weakling. Okay. I'm going to erase around this end effector here. Okay. Okay, so he's going to dab, and then he's just going to fall over, right? So we need the bow duplicated a bunch of times for consistency between the frames. Later, Chief Nelly, or later, Elpsy Congra, yes. Loading isn't hard when it's a simple 2D game. The problems where you keep stuff. Who should cache what? Yeah. I kind of have a blanket solution for caching assets, but I know it's not going to be easy enough for bigger games. At Bridge, when I get there. Yep. Later, fella. We'll catch you later. Mr. Kangaroo. All right, duplicate. All right, this is 12. Duplicate. All right, we're in the 15th frame of our animation here. It's going to drop the bow, dab. Let's just play up to there. So that's from 0 to 15, that's 16 frame. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's just hold there for now. Let's 16 frames. Right, save, export. Okay. Images. Dying. Can play it 12 frames per second. Maybe slow that down a bit. Let's go to 10. So 94, 95, 96. Plus 16 is 102. 112. Minus 1. So we're going to do that. Let's just get the state stuff worked out here. Okay, so we have dying and dead. Dying, dead. Okay, then the last piece is how to halted. I kind of want to break this stuff up into arrow update, halted dxdy. So these are if we hit the bounds, that's fine. Check for head impact. And we will cheat in the beginning so that I don't have to shoot super accurately. Robin Hood's head is roughly at 46 pixels off the bottom of the screen and has some radius. I have something in math. Distance squared. What is the radius of my noggin? That's a good question. Yeah, this might be a very long animation. We're 16 frames in already and haven't started falling over. Hey, Suki LePlante. Made it possible to render a map through a JSON. Super cool. Map rendering is tight. Super easy, barely an inconvenience, right? Okay, so our dab is there. So the radius of our head, if I measure, that's a width, which is probably good enough. It's from 442 to 417. So 442 minus 417, 25 pixels in diameter. So as long as I'm within 25 pixels in the center of the head, if distance, well, it's 25 is the diameter, so 12 and a half squared is what? Right around 150-ish? Math distance squared from front x, front y, Robert rectangle x, Robert rectangle y is the foot minus renderer scale. I forget, it's like 46 pixels. Doesn't really matter just yet. Our distance is less than 12.5 times 12.5. The inconvenience is that I have to manually make all the values. Yeah, so you need a JSON exporter from your editor, your map editor. Making a map editor is a non-trivial task, but it's so satisfying when it works well. Okay, so this thing's going to halt. Okay. And our back off is in the direction or the amount of distance we are over. So both head, arrow, distance. Because we need to reuse this value. Head, arrow, distance. Both hit, distance. These are squared. Then our dy and our dx are the direction of velocity times the amount that we're over. So yeah, that map editor is nice but awesomely hard because it sounds really fun to make a vertex editor. It's only for vertex shapes. Okay. Well, maybe that's not too bad then. Certainly non-trivial, but if you're just moving vertices around, that's not too bad in terms of an editor. Okay. So we need to determine how much over we are. So the square root and must be convex. Yep. Yeah, forcing convexness is another problem, which is non-trivial. I mean, you could accept point clouds and do like a hull algorithm to find the outermost points all the way around the hull. Still doesn't really guarantee you I mean the whole algorithm is convex. So head arrow distance so the corrective distance, correction distance equals the actual distance and how much over we are, 12.5. Then our dx equals our velocity. So where's our normalize? Math normalize the address of Vx, the address of Vy, then dx equals Vx times the amount we have to correct our distance, and the same thing for dy. Set Robert state to Robert state dying. And dead does nothing. The other switch statement, we're going into dying. Then we need Robert dying. I think is what we called it. And if it's dead, we don't do anything. But things like update, so I guess it's the user input, right? Handler, this thing. If enabled and Robert state not equal to dying. And it's not equal to dead. So if we're enabled, we're not dead or dying, and it's a right click, then we do all the rest of the logic. So we can't do any more inputs after we die. Is that everything? Oh gosh, let's hope so. Let's see how that goes. Oops, we did not embed our software. We should do that. Where is it? Oh, for Pete's sake, our embed PNGs. Let's see here. Can't imagine the size of the JSON. Here's the thing, I think I could do something though. If I do a simple editor, just makes me able to create points and it gives out the coordinates. That would be super easy to make. Yeah, there you go. Always good to start with a first order approximation of what you need. Image warehouse. So that build kind of got screwed. That's all right. Yeah, make something that works. Then you make it better. Always best to start with the simplest thing. A complex system that works was invariably built from a simple system that works. And while we try to reduce complexity, any reasonably complex system requires a similarly complex amount of code. The complexity we don't like is the unavoidable. Yeah, that didn't work, right? So. But either way, if you require convex shapes, you at least need a test for is convex. Even if your editor doesn't force the output to be convex, even if it does, like you still, since it's JSON, it's hand editable. People are going to mess with it, including yourself. I'm not saying like, oh, you'll have tons of users and they'll all abuse the system. It's like, you'll forget the rules, you'll do something, you'll be like, oh, I'll just move that point a little bit. And then you break your whole system, right? Even if it's just in the search. Let me go move that image a little bit by name. It's best to be consistent if you can. Active projects, word sleuth, assets, images. Wherever Robin went, turning that into Robert. Or Robert of Loxley. Not what I wanted. All right. I decided to mix between functional and OOP would be great. I have this mess. Pixel into world, game into float, mouse get position. My whole game relies on vector to floats. Yep. Functional is not exclusive of object-oriented, but and it's even nice in some ways because you have guarantees that state is not being mutated in certain circumstances. But a game is inherently stateful, so there's always one piece at least of the game that you're going to have state that breaks the functional rules, right? So that's just always part of the fun. Let's try that again. Yep, vector 2f. So you better hope that vector 2f has a very efficient copy constructor, assignment, whatever. Maybe I'm not understanding your use of the word functional. If I can break up a function or if it is an algorithm. So my understanding is that when you have functional means you have only immutable inputs which go into a function and generates some output. So the inputs are never modified, whereas in object-oriented, what you often end up with is you pass in mutable state, and that goes into a method. Right, so every method has an implied this pointer, and then you may generate output in addition to updating the actual state of the thing that you used to call, right? So method binds the this pointer, at least in C++, and hit whatever you call it in other languages, self in Python, blah, blah, blah. Method has the implied this, and then you both get an output, potentially from your method or not. But mutating state is a very common event that happens in this mute. So they're not exactly exclusionary. Like, you can do object-oriented style programming with some functional sections, but ultimately they are kind of different things. State is not mutated in a function in a functional language. Now, most functional languages also have options to mutate state built in. Like, it just turns out that maintaining state is too useful of a thing, but the mathematical guarantees of the functional calls is awesome. So a little of both. You can mix and match some. Renderer. Like, I'll use the functional if I can break up a function or if it's an algorithm. Functional is basically just input maps to output. Yeah, but I would say that 95% of the code is OOP and 5% is functional. Okay. That makes sense. I was gonna say that they're kind of mutually exclusive, but not quite. So the 95% makes more sense to me. That is something you can probably do in your system. Okay. So we want to shoot. Well, that wasn't at all correct. Walk. Thunk. Hey! He did it! It worked. I know there's nothing we can do with him. He's useless. We can't right-click the arrow. Yeah. He needs to hold that dab for a few frames. Oh. That's hilarious. I really don't know how I'm going to get that arrow to stay with the head while he falls over. But that basically worked perfectly. I think I want that head to tilt. That's funny. Okay. So back to GIMP, I think. I prefer to use OOP for structuring a basic engine. Structuring, yeah. Okay, so let's go back to GIMP, where we have to reopen our file because we renamed it. Oh, no, not that one. Assets, images, Robert. Okay. So we have reopened Robert. And I want that head to tilt. That is a thing we want to do. So let's share our GIMP. So let's see, when you dab, I guess the head rotates the whole time, doesn't it? So maybe what we do, so we find the right frame, it's 11. chop the head, paste the head, to new layer, and then we want to rotate it. Layer, rotate around the neck. By like 5 degrees. Nope, not for me. Okay. I'm going to duplicate this one, move it down to 12. And erase the head, so head 11. Head 12. Eraser. Head 13. Move. Now, layer, rotate about the neck. Maybe another 5 degrees. Okay, I think that's fine. Rotate. Duplicate. This is head 14. Erase the old head. Oh, not that. I said 4. We should turn on the background so we can see a little bit better. There we go. Hit 14, duplicate. 15. This guy, we must erase his head. Yeah, the dab just looks better if you tilt the head more, I think. I think we'll tilt it one more time. Then we'll give like 3 or 4 frames of him standing in the dab where he falls over. I think that's the right way to do this. Layer, transform, arbitrary rotation around the base of the neck. We'll go 7. Okay, so all these heads we need to merge down. Okay, 9, 15. We need like 4 of these frames, so 16, 16. Oops, okay. There we go. Let's see here. Duplicate 16, 17. You know, 1, 2, 3 final dabs. I think one more. Let's go to 18. Duplicate. Okay. Export. Now instead of 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we're going to add 3 to the animation count. Instead of 111, it's 114. Boom. Okay. Everything related to components of a game engine would be coded less in an OOP way because they're separate from the main engine. They're just functions that you give input and it gives you an output. Right. Makes some sense. Actually, we're in dead. Has to be not equal to aim and not equal to Yep, well, there's always more than one way to skin a cat. Lots of different programming paradigms. Some of which are actually quite interesting from a theoretical point of view, but almost impractical for anything real. But OOP and functional are fairly strong choices. I'm kind of mixed opinions about OOP. I think most of what I want from OOP is not all the things that it offers, but so I'm probably more of a I don't know. I don't know. I waffle back and forth. There are some bad aspects of object-oriented. Lots of videos about some of its weaknesses from people far more eloquent than I. And you don't need C++ to do functional, or not functional, object-oriented programming. I have examples of using object-oriented inheritance, polymorphism within C itself. And it works pretty good. You do have to implement your own V-table, but that's, as a concept, not difficult. And I'm not even sure that V-table is the way I implemented it. Like it's technically a V-table, just probably not the same implementation style. Okay, so shoot ourselves in the head. We aim straight up. Give it lots of power. Walk, 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 walk. Come on, dude. You can do it. Oh, he missed. He failed to shoot himself. All right. Try it. This way. Run, 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 run. Come on, dude. You can do it. Oh, too slow. What is this guy doing? Am I not shooting high enough? Let me shoot a little higher. Go, 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 go. I have shot myself in the head. There it is. Okay. Did not dab or drop the bow. And that might be related to this line I just put in here. Oh, yeah. It'll loop that for now. Let's see. I'm actually shocked at how good this worked without too much work. Set convert state to dying. Maybe we do that. Put that back in. Unclear. So I don't want it to go to dead too soon. It needs to go dying, then dead. So it plays out the animation. Gelid. Good word. Okay, march, march, march. Shoot. Run, 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 run. Thunk. Oh, missed. Not nice. Go, 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 go. Oh, stuck. Stuck, stuck, stuck. Go, go, go. Go, go, go. Oh, perfect. More time, more time. No, no time. All right, my dude. Nope, stuck, stuck, stuck. Oh. Oh, that's perfect. Oh, he's too slow. Okay, all right, all right. Is he decelerating because he's at his destination almost? All right. surely we can shoot ourselves in the head. Done it plenty of times in software. Donk, run, run. Thunk, dab. Okay. And it doesn't loop. We're good. But what? The arrow. The arrow probably should fade. Because there's no way I can keep it attached to the head properly, is there? Because the head's going to rotate and... Do we fade the arrow? Animation. Get animation. Set duration 0.05. Use real scale time defaults. Set our range. We're going to go from 1 to 0. And we want the arrow. Arrow. I think it's just called arrow. Good job, me. Oh wait, even better. We just say retrieve arrow. At the index. Oh well, we can do that. I think that's it. So, and then we'll just go back where it's done. That's probably easier. Okay. So we gotta shoot ourselves. Go. Oh, it's stuck. Okay. Run. Bunk. Okay. We have dabbed. I need to fall over and die. The arrow goes back. Action sequence with 2 actions. Set wait. Oh, interesting. Set wait. Set wait. Okay, we need to pass some of these through here. Bool is scaled time equals true. And then action sequence. Okay, so there we go. We can now do that for our archer. Set weight 0.25. Don't use scaled time. Then we retrieve the arrow. Sequence 0.2 set immediate. In the first step, to this thing. Does this work? And then it's done. Okay. I think we're close. Index is not captured. Oh, fair enough. Fair enough. Yeah, okay. All right. Rebuild. There we go. Then we need them to fall over. Okay. Walk, walk, walk. Draw the bow. Run. 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 Thunk. Okay. Now I make him fall down. We're only checking for headshots too, so it's not that bad. Okay. So what that means is I need to come over to GIMP. Duplicate. Duplicate. Okay, what we want is the head and arms to all fall kind of at the same rate. So the torso is basically going to get shortened. And maybe the hand falls a little bit faster. But the head and shoulders kind of fall at the same time. The knees start to buckle. So what to do, what to do. We want the head to accelerate its way down, basically. I mean, just sort of accordions, right? I wonder if we can cheat this. Duplicate. It's something that's reasonable with just scaling. What is this? We can scale. Layer. Scale layer. Five. I only want to scale on one axis though. Layer, scale layer. Oh, there we go. 1, 2, 3, 4, 5. Yeah, I'm not sure. Duplicate. Erase the duplicate. Take the original. Paintbrush. Grunge. 8. White. We want this. Head. To droop. Torso. Actually, let's go ahead and drop the shoulders some. Shorter hips. Okay, move. Oh, yeah. 8. Oh, yeah. Our racing is never very good. So 19, that's probably okay. Eraser. Okay. 8. All right, so there's our 21st frame, 22nd frame, but yeah. Move. Eraser. Paintbrush. Back to favorite setup here. 8. Okay. It drops even further. Honestly, at this point, like things just kind of mush, right? Things are just kind of like, blah. Nope, not that. Not that mushy. All right, it's just, ooh, whoa, okay. All right, 21. Got 1, 2, 3, 4. We can do a few more here. So this one gets deleted. Duplicate. Well, shoot. 19, 20, 21. There we go. 2. All right. Duplicate. Erase. Paintbrush. And like literally just everything's kind of a blob at this point. Maybe the foot's kicking out further. Good afternoon, Javeth. How's it going today? It's going pretty good. It was shockingly easy to shoot ourselves today. I worked out the code for... So now we're just animating the death cycle. And basically just about done with that. So yeah, it's actually working out pretty good. I thought it'd be harder to code it up, but it turned out to not be that bad, which is always encouraging. Got a few more frames to go for death. I think it would be funny if we like had it as a game achievement, but I can't get the achievements to work from Steam with the way I do things, so too bad. So this one, transparent. This one, we're going to erase everything. And then so he drops the bow and dabs. It's gonna be great. Is he doing the dab? Yes, he's doing a dab before he dies. So he drops the bow, then he dabs, then he's gonna collapse. He holds the dab for like 3-4 frames. It's gonna be great. Nice little Easter egg for people to find. Okay, so acceleration. People fall a little faster. Oops. And yeah, basically at this point, the whole body is just kind of collapsed. Maybe another frame or two of that. So I'll put, well, maybe 24. 24 will be probably enough, right? Nice. Yeah, it's kind of fun, I'm enjoying myself. I do have somewhat of a macabre, morbid sense of humor. So we'll inflict that on the world. And some people will find it amusing and others will not. There's not much I can do about that. I think all we really need to do... Oops. Move that up a pixel. There we go. Okay. Paintbrush. 8. Okay. Then the funny part, maybe. So I'm going to delete this layer. Duplicate this guy. Grunge. 4. Six. So this is our longest animation by far. And I don't know if it's going to turn out looking okay or not. We're just going to try it, see what happens. Nope, not that one. Nine, almost there. Actually, that's probably good enough. 29 frames, which is actually 30 because we start at 0. So we're going to go out to 30 frames. File. Oh, let's see here. Hide our background. Save. Export. And then 96 plus 30 is 126 minus 1 because it's inclusive. All right. We're going to see how the whole animation plays out. And I don't really have a good notion about the death. The falling over scene. Animation is not really my forte. So we'll just see how it looks. And that will be good enough for us. And what are you doing today there, Dravest? I think we throw some sounds on this guy. See how it goes. Do I still have my sound library up anywhere? I think I do. Because we want a wood thwack for when the arrow hits the wood. I want a squish or a splat when he gets shot. Or just an is Wilhelm screen public domain? That's a good question. It's not entirely public domain. Darn it. Has been used extensively. Its original recording and subsequent mastered versions are still protected by copyright. So I can't use the Wilhelm screen, probably. That's too bad. 2 o'clock. All right, see how it looks. We may slow it down further. 8 frames per second might be slow enough. Okay. Shoot up, up, up. And run. 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 Thunk. Dab. Oh. That cracks me up. And nothing else is interactable. Not bad. Not bad. Okay. Actually, I think I'm just going to call that a win right there. We're going to say journal. Animate Robert dying. Death state does not allow any interactions. Sounds. Target. Other idle animations. All right, we're doing good. Doing good. Robert now dies and becomes unresponsive. Okay. Now, we need to share. Does this one work? No. All right, if I remember right, the only way this works is if I bring this window over here, then we share, then I bring it over to the audio. Here we go. So we need a wood block sound. Oh, really? Hops? I thought there was like a wood, maybe an etc. Wood block. Whoa. And this might be the best wood block we've got here. Musical? Wood block? Nope. I guess that's the reason. Etsy wood block 1. So that's 1. Is there like a twang? It'd be nice if there was a twang. So I've got to move this sound over. Sounds. And the other folder, my source folder. Resources, sound, WAV, and it's Etsy woodblock 1. Okay. Woodblock, trash bin, break. What, like a twang stapler? Nope. Musical? Is there like a string pluck? What, like a twang? No bongos. No. Well, definitely not that. Wood block. Nope. Musical. Maybe a glass? Nope. Nope. What are the things that say note? Nope. Marimba. Don't think so. Zap? Zap cling didn't sound too bad. Oh, no good. Eesh. Also, it sounds kind of like a twang if I can, but so far it's not looking great. Oh, what else do I need? Like a... Oh. Definitely not. Chimes? I don't think any chime is going to sound right. Maybe pop drip mid is the closest to a twang. Pop drip mid. Maybe that's what we'll do. Pop drip mid. So there's two of the sounds we want. Maybe. Target and death. I need a death sound. I also need like a hit the target. Maybe pop zap. Pop zap. Let's pop zap bass. Actually. No. Try pop zap. Okay, I need a death sound. Sound for death. Space alarm is plenty loud enough. Or maybe take like an error sound, like a near, or a slide. Hmm. I want a. We have Pixabay, where we get a lot of sounds. Maybe we can do Wilhelm. Not images. We want sounds. Sound effects. Wilhelm scream. Female Wilhelm scream. Nope. See here. A 4-second scream. Safe filter for a scream? That's bizarre, but okay, I guess. Smirnoff scream. Ow! That's too long. I think we only have about a second. That's very loud. Very loud. Nope. I'm leaning towards Smirnoff. That's just kind of funny. Wilhelm splash. Let's just go with the Smirnoff scream. Ow! Okay. I like it. Okay, now, I think what that means is we're done with the browser. Source about scene. Contributors. This guy's name was Glazkov. Okay. So I got that downloaded. It's called Smirnoff Screen. Do I document this stuff anywhere? Okay. Now dies. Full animation. Found a yell sound. Smirnoff scream. Okay. We're going to add these other sounds now. So where's my Smirnoff scream? And I need to put it in this folder. I downloaded it somewhere. There it is. I guess we need to turn that into a format we accept. So let me bring up an Audacity. And then I guess I should share Audacity. Too many things open all at once here. Okay. Audacity. Where's Audacity? There it is. Okay. There's my Audacity. Now, we are going to select everything, duplicate. Then, not that one. Make it a stereo track. Then we export as WAV into the right place. Active projects, word sleuth, assets, sounds, Smirnoff screen, whatever. Okay, so that should put that file in there. Okay. Okay, so we have pop drip mid. .wav. We have pop zap. I gotta remember which one's which here. So pop zap. Oh, that's not the, yeah. Etsy would block 1. I remember that one. That'll be the arrow hitting a thing. So pop drip mid. Where is it? Okay, pop drip mid. Pop mid, pop zap. We need the Smirnoff screen. Pop zap or pop mid? I don't actually like either of those. Let's see here. Oh, pop mid is already used. So then pop mid. We had planned for something. Pop mid. Unless pop mid is already in use. Pop trip, pop zap. Was I really planning on using pop zap? Sure. All right, let's get these all done here. SFX. This is not that loud, so we can go pretty loud. Side 0. Oh, wait, pop drip mid. Pop drip. Arrow shoot. Pop zap I'm going to use for arrow hit. That's plenty loud, quiet enough. It doesn't need to be. Arrow miss. The wood block. Let's see wood block. How low do I think that needs to go? Okay, Smirnoff screen. That's kind of loud. So I think we'll do it at half volume. Just so we don't blow out anybody's eardrums. Assets, sounds, Smirnoff screen. Okay. embed our wave files. Oh, shoot. I have to go re-export the Smirnoff screen. All right. Okay. I forgot to change the sample rate. This will only take a second. Duplicate, make stereo 44,100, easy enough. Export it as WAV. Okay. Re-export it. Let's try that again. Screen went fine. Okay, good. Then we apply some sounds. Well, let's first do the build out. Make file. We want to update the sound warehouse. All right, we're getting there. Adding some sounds. This shouldn't take us too long. So we need arrow shoot. Oh no. Hit. Darn it. We'll restart the build. It wastes at least enough time to do it that way. Okay. So arrow shoot, arrow hit, arrow miss, and the scream. Those are the main sounds we'll need for our dude. Oops. I kind of want this dying one to be a little slower. Make sure we got it all in there. We did not necessarily follow the features, the flow the way we should. Got 2 or 3 more songs on the way. At this point, just safer. Okay. Oh, now we have to wait for a few minutes. Oh. Okay. So our death animation is gonna be a little slower. have those 4 sounds ready for use. And we just need to hook it up in the right places because we have basically release, when the arrow impacts and is halted. Only if it's the wall. If it hits our dude, we play a different sound. And if we hit the target, which we have not implemented yet, will also be a thing. Yep, we'll be here for a few minutes. So that's an head impact we want. Scream. Scheduler. Get sound. Set use scale time to false. Set volume will be some amount. Let's do that for now. I call it play. Okay, the volume we compute. If sound asset equals arrow miss, and our volume equals that remap math magnitude squared of v x vy magnitude is less than something. Magnitude is greater than some amount. We have a max velocity, right? Underscore max velocity. We got our magnitude from 5.0 to max velocity into 0.125 to 1. All right, pretty close to being usable. And it's going to get a comma instead of a semicolon. We'll see how it goes. All right. See if we get any sounds. That's all arrow hitting stuff. If we shoot less hard. Doesn't seem to scale. Okay, interesting. Run and run, run and run. We're not gonna get there in time. Okay. Go, dude, go, 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 go. Oh. Oh, missed. Go, dude, go, 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 go. Come on, keep going, keep going. Way too slow. Wow, okay. Go, go, go. Oh! That makes me chuckle. We might want to wait just a scotch before we do that. So, arrow miss. If it's not, we actually want to put in a short delay. Nah, do we? That's fine. Where is shoot? Where's set Robert State shoot? Aim. Handle mouse press. Oh, it's in fire. Fire arrow. Set user scale time to false. Set file, which we called arrow shoot. Okay, and volume equals 1. So if we're going to yell, we do the full yell. Otherwise, we do that. So what is our magnitude? That's a good question. Oh, this is magnitude squared, but it's okay. We just want to know kind of what our values are. Then we'll remap everything. It'll be fine. Okay. So we just want a teeny little arrow drop. The magnitude was 24. Holy smokes. Okay. If we shoot real hard. Wow. If we take the square root of these, they're not that big, but 1, 2, 3, 2.2 million. Oh. Let's try to shoot ourselves real quick. Run, run, run. Oh, we are way too slow. Okay. Go, 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 go. You can make it. I'm amused. Okay. Maybe we just get this as magnitude, then we don't have to take any square roots anywhere. That scale is way off, so. It's one square root, it's not inside of an update loop, it's one time on an event. Taking a square root is not going to kill my frame rate. Okay. All right. Okay. I think that looks like a better range. 150 to 1505. One fifty, 150, 1505, 15. Actually, just go to 1000. Then we're going to remap from 150, 1000, something like that. And that should do it. Very soft arrow hits should be quiet. Harder arrow hits should be louder. All right. Very, very soft arrow hit. Yeah, there's some variation. Yeah, good enough. Now we shoot ourselves just for good measure. Go, 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 go. I feel like, oh, you can only shoot yourself going right. Is that true? Because the drop bow animation takes longer. Because it's a few frames longer, you can't. Okay. So we have those three sounds in. We shoot, sort of. We walk, and we die. Scream. Sounds added to Archer Dead. Target and scoring. Do we want to do that? I think so. Let's see. We're at almost 3 o'clock, so we can do scoring. Now has sounds. I don't like some of the sounds. Maybe we do find go find a twang on Pixabay or something. Yep. Yep. Oof. Eesh. Those are pretty bad too. Actually, this one doesn't sound bad. Bow release. Maybe go with this one. Maybe I just download this one and put it in. This one might sound better. Okay. let's go do that. Audacity. Oh, Audacity's still up. Okay, cool. Oh, wrong one. Wrong keys. Wrong keys. There we go. Okay, so we have a left and right channel. That's a very low sample rate. Export as WAV into sounds. And that's basically it. Arrow shoot. Unfortunately, we have to re-embed our audio. I think one of these days we might write a user interface around this tool that, well, I don't know. Yeah, whatever. Take a few minutes. Yes, yes, yes. Our little archer can shoot himself to death, but only if he's walking left to right. Okay, very nice. So next thing up is going to be a target. A target. And I'm thinking we can make something fairly simple. Hmm. We can only check collision on the vertical axis. There will be no depth, so you just shoot high or low. Let's see here. I need ideas on how to make a 2D target. Or, wow, that's... Woof. That's lame. They're all lame. Lame, lame, lame. All right, we'll fix some. It'll be fine. Let me turn to GIMP while we're waiting for that. So let's over here to our favorite archer. We're gonna make a new layer. New layer. I don't want it in there. What are you doing? Okay, we want target. And I think all we do is we come up 80 pixels. So we're at 156. Oh, let's see here. 1023 minus 80. 1023 minus 80 is 943. 943? Or we go 64, 64. 1023 minus 64. 959. There, that's a rectangle. And we need some circles in here, so between 133 plus 32 is 165 is the middle. That looks about like the middle. Build is still running, making sure I'm not wasting too much of anybody's time. Ellipse select. Expand from center. There we go. So there's one. And we want paintbrush, grunge. I don't need pixels. Stroke selection. All right. Yeah, maybe a little bit smaller. There's our target. Layer to content size is somewhere. Layer to content. That does seem a little odd. Layer boundary size. Make it one wider. It'll make it there. Target is at 133, 959. 133, 959. Target 133. I don't remember the number. 959. Yeah. 959. And it'll be 64 by 64. Okay. Just make sure the arrow sound is correct. Okay. feel like there's a delay. I feel like the arrows are on a delay. Encomium. Let me go look at that sound again. Right click, edit with Audacity. Oh, come on. Pete's sake. Okay. Audacity. Audacity. There you go. Okay. Now, if we load this up, and there's a lot of dead lead up time. There's actually quite a lot of dead time at the end. Oh. Put the... Okay. Put it back where it was. Into sounds, 16-bit PCM. Yes, okay. Now there won't be any delay. We got to re-embed all that data. Okay, so we've got to do that. So we have to re-embed our sounds one more time. We have to re-embed our image data because we've got a target. So we might as well do a little bit of things here. Target. The target renders before the arrows. Robert, and we get UV key target. Capital T target. Target needs these three things as well. We need UV key target width and height. Target dot set rectangle. Rectangle 0.0, 0.0 width and height. Okay, then when we set bounds for target, move to set rectangle. Target dot set center width over 2 and height. I like that way of thinking about my target positions now. Set bounds. Move Robert underscore target dot move to r dot width minus underscore target dot. Is there spacing in here? No. Rectangle dot width to rectangle dot height. Renderer scale by 10. This way makes my brain a little happier. Okay. All clean and debugging. One last round of sound. A new image. So many things. Okay. With the target in, we will have to detect target hits as well. And what we have to worry about is if our Y is in the right range for our arrow, and if our X basically we need to do line-line intersection. The target's going to have a vertical line. Oh, it doesn't have to. Well, there are a couple of tricks we can play here. Well, maybe not. Maybe there's not a good trick we can play here. Think about this. So I want the arrow to hit the target. It means that the arrow passes through a line segment. We have the arrow's head. We have the arrow's center. The arrow I need a line segment intersection. That's not the worst. Line segment interaction. First, you see if the two lines will intersect. Not one is easy enough. Actually, should be. All we have to do is check if one or more endpoints for our arrow is in the rectangle of the target. Or we can do a radius check on the front end. That's actually the simplest. Is that the simplest? The front of the arrow is within the radius, and if the front of the arrow is past that midline, which means we kind of need to limit our dude to 65, 75 pixels in travel, which is easy enough. So if we go to Archer, where we walk, where we set him to walk, the handle mouse click, handle mouse press. So here where we clamp the destination, it's greater than rectangle width minus the width of half width of Robert. And we also have to subtract the width of the target. also the width of the target. Max x equals plus underscore target dot width rectangle dot width. Actually, just the left edge of the target. I think that's it. Now we won't walk up to the target, I think. You can stand next to the target, but you can't go through the target. Probably for the best. Oh. So we need the arrow to hit the target. Then we need to keep a score based on where the target was hit. And then the score resets when you retrieve an arrow. All right, let's see if the... Did I export the target? I sure hope I exported the target. Otherwise we have to rebuild. I'm not sure I did. Luckily, it doesn't take as long if we don't worry about sound. We have to do something about sound though. Target, yeah. Yeah. Okay, we want to we did forget a step. Okay. That should fix it. Or something. Target. I think if we're within radius, if the front of the arrow is within the radius of the target, then we check if we're past the midpoint. And then we do the same back off algorithm, play a different sound, and compute a score. I think that's the right way to do it. There's a million and one ways to do it, but I think that will be the simplest. Okay. Close. I'm gonna do the same thing here. Let's probably copy paste. And it looks like it's gonna build. Okay. So hopefully the arrow shoot does not have that delay when we release. And hopefully the target shows up where we expect, sort of, mostly. All right. Okay, that's further than I would think. Still feels a little bit like there's a delay. Why is there a delay? What is this delay? Shoot. Yeah, it should be like 0. What about file size? That should be 22 kilobytes. Yeah, that's not much. That's not sure why there's that bit of delay. Oh well. I think it's close enough. Okay. So detecting a hit. Detecting a hit. Set bounds. Over 2. Yeah, let's remove that offset there. Just move it further into that edge there. Okay. I just want to make sure that our dude doesn't walk past the edge of the target. That's an important factor. Whoa. Okay. Well, that's wrong. Max X is the width minus half our width and the width of the target? Nope, nope. Max X equals the X coordinate of our rectangle. This might help. Almost. You have to take into account half the width of Robert of Locksley. So I should put Robert right up next to the target, but never past or into it. Walk left, walk right, that all works. If we try to walk past the target, it's not great, not gonna lie. not a very good shot yet, am I? Doesn't matter, we're not really keeping score. Okay. So somehow we're walking too close to the target. Yeah, we're overlapping. So Robert's width. Oh. Nope. So it's target dot rectangle dot width plus this mess all divided by 2. That's going to be a little bit more sensible. Because our X position on the target is from the center point, not. Okay. Arrow target collision detection. We're going to get that next. 3:19. I figure it'll take us half an hour to get that correct. And then scoring. Scoring won't be too hard. We can probably have the scoring done in an hour. Okay. Let's go walk over to the edge of the thing. Yep, can't aim any closer. Let's get. All right. Too high. Okay. Arrow target collisions. Here we go. Okay, update. Check for head impact. Check for target impact. And there's an alternative sound. That is for arrow hit, not arrow miss. So, let's see here. Target arrow distance equals math. Distance squared from front x, front y, to underscore target dot x to underscore target dot rectangle dot y minus underscore target dot rect dot width over 2. Okay. Let's just compute the distance. If our distance is less than target rectangle width over 2, then all we really have to do is check these points and set the sound asset. arrow hit, arrow hit. We don't have to check that direction. We just have to check if our front is greater than underscore target rectangle dot x, which is the center. Underscore target rectangle. Then we choose arrow hit. Do this. If it's a hit or miss. Is that it? To do compute score based on height. Okay. Let's see how this goes. If we can shoot the target, that's like 99% of the work here. Distance was not right. Target arrow distance. Now, possibility, we lob it straight up and it lands on the far side of the target. So this doesn't quite work, does it? It should work for most cases. Just because I'm pathological doesn't mean that everyone is. But we probably should find the pathological solution, huh? All right. Arrow. Wrong. A little more. Whoa, 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 well, wow. It did something. Nope. Huh. I'm not too worried about it, but it is interesting. Our target arrow distance is less than half the width of the target if the front is greater than target rectangle X. We halt target rectangle dot X. Why are we doing that against Y? I don't know. I don't know why we did it that way. But X is probably the right number because that's the center line of the target. Like I said, we can maybe be pathological, although the 80 degrees limit on the angle might make it very difficult to do it what I'm pathologically thinking. Okay. Let's just get nice and close and Bonk. Swap back. A little high. Okay. A little high. Nope. Oh, it hit. Oh, so that's what I'm talking about with the pathological. I can lob it over this line. would it still count it? If we get up close, can I shoot a high angle arrow? Close. A little low. Good heavens. We move closer. Oh, come on. I'm gonna shoot very steeply up. Basically, there's an imaginary line right here. If I shoot over the top of that line, oh, that actually is pretty nice right there. All right. Ooh, it's a miss. Can I do it? Ooh, I almost can. Nope, no good. Oh, this might be the one. Oh, so close. So it's bottom of the E there. Oh, yep, there we go. That was the pathological case. Oh, okay. So line segment intersection. Is there an easy shortcut that I don't know about? Maybe. Three points. That doesn't help, does it? Shamos-Hoey algorithm is not helpful. Huh. Vector cross product. Define the two line segments. Any point on the first line is representable. Two lines intersect if you can find T such that whatever. Cross both sides with S, getting in since, and therefore solving. Determines the intersection point is based on algorithm in Andre Lamoth's trick of the Windows game programming gurus. Lamoth then uses Kramer's rule to solve the equations themselves. Kramer's rule is a little matrix thing. I can test that it works. Edge cases. All I want is, does it intersect? So this is the Andre Lamoth's. So this is what I've Googled up. And all I want to know is, does it intersect? No, I think we can cheat. I think we make this easier. Front X, front Y. Compute the rear X and the rear Y. The rear X point and the rear Y point. Rear X minus the amount. If front X is greater than, and if the rear X, that's the M, if the rear X is less than, then we're done. I think that's it. We've already checked the distance. So I think that's it. All right, let's try that. It is a pain to try and get the arrow launched in the right place for testing that, but we probably should be a little bit thorough. Okay. Might take us a few arrow launches. Okay, so we're going to stand over book 3. We're going to shoot very steep angle. Okay. Shoot a little harder. Uh-oh. Oh. Okay. So down here in the B is not quite right. Ooh, close. Okay, that does miss. Perfect. So if we aim a little bit shallower. Okay, so where's this above the O? Ooh, not quite hitting it. Need our arrows back. Okay. We are hitting. So we need to take score now. How cute, how cute. Okay, what I need to know is where on the y-axis are we hitting? Go to Archer. The front y plus dy. Quote. Final y equals front y plus dy hit y 3f final y. Okay, that's one thing we'll need. Then and since it's symmetrical about 32, target rectangle dot that final y. Minus underscore target rectangle dot y target rectangle dot height divided by 2. Half the height of the target. Let's see if that makes any sense to me. Okay. So there's 3 white rings and 3 dark rings, I think. So ideally, for testing, we're gonna walk right up to this sucker. We're gonna shoot a little high. Shoot a little low. Minus 14 and 12. .7 pixels off dead center. I think 3, 1, 2, 3. Yeah, 3 white rings, 3 dark rings. So we just need to compute a score. That bottom one is darn near 32 pixels off, which looks correct. Okay. All right. Let's just take a fabs of the whole thing. We don't care if we're above or below. Then we just have to check the ranges. If final y is between 2 numbers, and I need to know what those numbers are. So where's my GIMP? I need to measure this. From about here at 1023 to about here at 1015. 1023 minus 1015 is 8 pixels wide. Let's just 1015 to about 1011. To 1006 to 1001. Okay. So our distance let me just check here. This is 990 to 996. So if we're between 0 less than 6 points equals 6. Else if we're between 6 and something else. So from 990 to 1002 is 12. So that tracks with my numbers so far. Points equals 5. We just go by 6 pixels every time. Well, in theory that would be 18. 18 from 990 to doesn't quite work out that way. 7, 18. 18 plus 6. 108, 116. 1, 2, 3, 4. That's not right. 990 to 996 to 1002 to 1008 to 114. 8 to 114 to 120. Okay, so I guess we just go by 12s and call it good. That's visually about right. So 18 to 24. 4, 3, 18, 24 to about 30. The last 2 pixels are not going to count. So we're going to make that 1.2, 3, 4, 5. Points and final line. Okay. Computing points. And then we'll add it to a score. We'll throw the score up on the screen somewhere. see how that goes. I mostly want to see that the points kind of make sense, whether I aim high or low. Okay. Okay. Oh, except it can't be 6 pixels, can it? Okay, a little weak. So I'd say that was a 4 points. 2 points. Yeah. Dead center, 5 points. Right, because it's 1, 2, 3, 4, 5. Two points. Can I get 1 point somewhere? Two. It's actually kind of hard to get one. There it is. Okay. There's our 5. Cool, cool. All right. Step equals renderer scale 6 pixels. 0 to step. Let's see here. Float low equals 0. Float high equals step. If we're between, zero times step and 1 times step. Two. Or maybe this is a better way to do it. Instead of doing all these checks, we say points equals final y over step truncated to an integer. Just do a little division, call it good. We also want a distance multiplier, but we'll get around to that. Let's go get some points. All right, walk over here. 0. Oh. 2, yeah, so we've got our logic backwards. One. 3, yeah. All right, so we got our logic backwards. 5 minus that. Okay. So that center one should be 5 points. Invital, good word. 5 points. 4 points. 3 points. 3 points, 2 points. Can we get the mythical 1 point? No. Two. 1. There's the 1. I don't know if I can get a 0. In theory, it's possible. There's our 2. Ooh, close. There's our 0. It hits, but it's a 0. Alright. So we now have enough information to track a score. And the scoring seems reasonable. Oh. Scoreboard. I have an ink score. I already have an ink score. M_score equals 0 to start with. When we retrieve an arrow, M_score equals 0. Arrow hit. Score plus equals points. M_scoreboard. Set text. Score modulus some amount, which is this. All right, so now we need to get the scoreboard displaying. To do measure distance for multiplier. Okay, so scoreboard, M_scoreboard, set text. I agree. It should render. I agree. Target, move to scoreboard set text. Basically that. Scoreboard dot set font store. Wow. Get from the font warehouse the asset known as eraser. Set text color. Something like that, maybe. And then set bounds. After we've set the target, set rectangle. X Y minus target dot rectangle dot height X Y, and those are not right numbers yet. And we might as well just take target width and height, right? For now, as a starting point. That should put it somewhere. M_scoreboard dot set font size render Scale 16 pixels. 24, 16. There's no way that this is correct. We just want to throw it up on the screen. Oh. When you retrieve the arrow. We need this thing. Set text size. Okay, fine. Okay. Oh, capitalization is hard. Typos are hard. Getting closer, getting closer. Okay. Let's throw it up on the screen. We'll choose a location and call it good. Basically, we want to be above the target and to that side of the thing. So let's go take a looky-loo and see if the score updates. Okay, so score is wrong. But it did update. It is technically drawing, so there you go. Set bounds. Let's do a little thinking here. 16, maybe go to 20. We set a rectangle. Basically, we want the width minus our width. So set rectangle. Scale. Float font size. Text width. Text height would be a thing. 30. The text width, let's go with 100. Set text size to font size. Our X will be rectangle dot width minus text width. The Y position will be rectangle dot height minus target rectangle height plus text height. And then we get text width, text height. Just see how that goes. Okay. Okay, here we go. 3, 8. So if we go double digits, 13, 17. It kind of fits Just needs to be a little bit more off the edge there. So we should be able to get a maximum of 30 points. If we don't take into account distance. There's our 30. I'm gonna try to shoot ourselves and our score should fall to 0. Okay. Alright, so score works. We just need to make it a tiny bit wider, which is not a problem. That's dead easy. We were just guessing the width. 25. There. Easy. Okay. Distance. Target flap is in. Target and scoring. Yeah, we're making good progress. 4 o'clock. We still got 2 hours, so we need. Well, scoring isn't quite done. Target scoring scoreboard. What else? What else? Distance. The total X displacement between the archer and the target. This to do is done. Measure distance for multiplier. So here's the deal. Robert rectangle X. Oh, I need to get this. Sorry. Okay, sorry about that. I was expecting that phone call, and I knew it would take a few minutes, so good, good. I have a yeah, so that's a different project I'm working on the side. Just taking a look, see at some different options to expand my real estate a little bit. Gonna take some work. Now, where were we? Oh. Okay, so from Robert to the target. Float distance equals um, distance modulus 0.3 float. We'll just see how far we're shooting and split it in like 4. If you're too close, it's not interesting. If you're too far away, well, it should be worth some points. Did I not? Way out. Just. Okay. Here we go. I think this might just about be the end of our archer doodad. Like, this is the last piece. Just a few things to do. All right, so if we march straight up to this thing, and we shoot it 65 pixels. If we run all the way to the edge, $805. So 65 to 805, 65 to 805, 66, 805, 740. It's about 740 pixels to our target. Ooh, missed. $805. $66,805. Okay. 66 to 805. 65,805. Okay, so here's our distance. Math remap our distance into 65,806. Then all will be scaled, which we should test here eventually. Into 0 to 4. Multiplier equals this cast as an integer. Times our multiplier. Just d mult So now should be a multiplier of 3 times 5. Might be a 15-point shot. So if we're close, should get no points. Move away. Multiplier of 1. Multiplier of 2. Multiplier of 3. Okay. So all I have to do is put some little chalk marks where that is. Short. Oof, some bad shooting here. £15. 18. 33. 48. 60. 75. So there's a theoretical maximum of 3 times 30 is 90 points. I think. $60, 75, 90. There it is. Theoretical maximum. And we shoot ourselves. Too funny. Cool. I think that's it then. We need to put some marks up for where you have to stand. Oh, so good. 90 points. So we know the distance. Remap 0.4. So all I need is some little tiny chalk marks. 4 of them. Set the score. Distance. Multiplier. Delta y. Points. This is final y. Points. Distance and the multiplier. Equals some number of points, which is points times mult. Okay, there we go. So we need in GIMP, and this is only going to take me like 1 second here to make a, well, might as well show the thing, right? We're doing a thing. Not Blender, I want GIMP. Here's GIMP. Okay. So we're going to make a new layer called Mark. We're going to rectangle select something like that. Edit. Stroke selection. Stroke. Move the mark. Actually want that there. We want to maybe something like that. Stroke selection. Move the layer. Layer, crop to content. It's the bottom edge we care about the most. So my cropping tool. I'm fine with that. And we just want the current layer. So there we go. That's it. Move this mark. Starts at 56 and 996. 56, 996. And its width and height is 9 by 24. Of course it is. 9 by 24. Okay. So save. Export. That means we're done with GIMP for now. Images. UV rectangle for our mark. At 56. 996. 9 by 24. I think that's that. We want to give some indicator that the further you stand, that the distance you are from it makes a difference. Positions of these we'll have to do a little bit. We kind of know what the math is. It's center of target to center of Robert. Between that range divided by 4. So we really only need like 2 marks. So let's do a tidy up and debug. Maybe just do a full clean. The sound, let me check the sound thing real quick. Maybe I need to re-embed that sound, but I'd rather not waste the time if it's going to do the same thing. Assets, sounds. Let me bring up the reload this audio skip. Yeah. Okay, so I did properly truncate that. Maybe we do just need to do this real quick. We'll put 2 or 3, probably 2 marks. There's the 0 point mark, the 1 point mark, or the 1 multiplier mark, the 2 multiplier mark, and then the 3 multiplier mark. So 3 marks, right? 1, 2, 3. Just do a full clean and debug. Then we'll put some marks in the scene for points. And we've still got the time to fade everything in and out of the scene. that'll be similar to what we did here in doodad ball. Fade in, fade out. In fact, it will be very similar to this. In fact, yeah, in fact, this is so close. We can do that. Oh, the ball. The ball. That actually doesn't quite work, does it? Let's look at the other doodad. Doodad. Pop bubbles. So fade in, fade out, and during update, if a bubble is if we're done, we're enabled. If we're not done, we're flip enabled. So that's okay. So the ball might need to be changed a little bit as well. Animates, animation. This one though. Action sequence. Get action sequence with 2 elements. Play the animation at 0. Set immediate. We want to turn the ball off. Underscore. What's here? Enabled equals false. Which happens in step 1, capturing this. There we go. So that should help quite a bit. Chuck Archer. Okay, so when we fade in, we don't do color. Set duration 1 second, set range 0 to 1. Floating point value. We're going to get a bunch of color stuff going. Yes, this is fine for it. Well, no, for fade in. Int alpha equals 255 times the value. Taken as an integer. Then, all the different things you have to draw. Chalk Archer. We need to draw Robert. We need to draw each arrow. We need to draw the target and the scoreboard and eventually the marks. Sprite has a quad, so we can pass those values through. Robert dot texture quad color. C dot alpha equals alpha. Robert text quad set color equal to C. Archer, num arrows. Texture quad arrow equals arrows plus index. And we get color equals arrow color arrow set color. Robert. Come on, I can't not type. Robert and target 1, 2. Scoreboard will be somewhat similar. C equals M underscore scoreboard. Text color, right? Just color. Set text color. I hope that's about right. Okay. Compilation, yes, your thing's broke, blah, blah, blah. Chop ball sequence. Okay. So the archer. In this case, set range is from 1 to 0. Fade out, turn it off. All right, see how that looks. Course. This is a dot, which means this is a dot. I do not know why that's there. I think it's probably also here. Copy paste things. Set immediate. Okay. I think we're super close. You just got to put the marks up. In theory. Okay. Distance on the y-axis were 3 points. That's about right. Distance we're standing away from it, multiplier of 3, 9 points. High. Yeah, that arrow feels, the sound is a lot snappier. Score 39. That should be the sum of these, right? 15, 15, and 9. Perfect. Score zeros when you retrieve arrows. Not bad, not bad. Okay. Anything else we need? Honestly, that feels pretty good. Journal. Starting, scoring. Oh, the fade in, fade out. We did not actually look at that. Wave and bow. Okay. Now, we need the 2 marks. Oh, I was going to watch the thing. I keep forgetting to watch the animation. To see if it fades in, fades out. Okay. Alright, my dude. Fades in. Fades out. I think it's good. We'll do it with some arrows around. Ooh, missed. Let's shoot ourselves. Just for the whole experience, right? Run, 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 run. Wow, we were too slow. All right. Run, run, run. Oh, we missed. That's embarrassing. Can't even shoot ourselves. Here we go. Run, 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 run. Ah. So actually a low shot might be easier to get under. Shoot. Ow! Dab. Die. Surrender. Yep. Fade's good. Okay. Everything's working. We just have to put in those 2 marks. So, Archer. Texture quad mark. 1, 2, 3. Nine, 10, 11, 12. 12 children, child items. Mark 1, 2, 3. Okay, where else the targets are happening? Let's get the mark 1, 2, 3 in there. Okay, where else? Where we check for target impact, we don't care. Mark 1, 2, 3. Okay, here's where the marks need to get placed. So we'll mark that. Set texture, set UV, mark. Mark. One, mark 1. 2, 2, 2, 2. 3, 3, 3, 3. Okay. Then we do math, we don't care about that. We can actually do this a little differently. We can make it so that the score multiplier is not based on distance, but based on which marks were left of. So, if I'm going to score Robert rectangle.x is less than, I'm going to score mark 1 multi equals 0. If it's greater than mark 3, multi equals 3. Else if, well, mark 2, mult equals 2. It's greater than mark 1, multiplier 1. Otherwise, it defaults to 0. There. So instead of this fancy remap and distance, it just depends on the distance from the marks. I think that's it. Okay, so we just need to place them now. Target. Move 2. Mark 1 is the closest. Move 2. R.H. 1, 2, 3. And I don't really know how I want to do this. Like half, quarter, eighth. We could do R.W over 2. R.W over 4. We can do it R.W over 8. All right, let's give it a try. Tidy up and debug. Should not rebuild my asset library warehouse things, so it shouldn't take too long. As long as we're behind the mark, we should get the points. That's the theory. Oh yeah, good stuff. Assuming they show up and render correctly. And then I embedded all the image data the way we needed to. Overall, not bad. Super close. But I promise, after today, no more Archer. In fact, rectangle.x. 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 Super close. One more try. 5 hours in, we've still got an hour. We might do doodad switching. We'll pick up a little piece of chalk and a little fake chalk eraser. One, two, I don't see the third. Oh, the third is where I'm standing. So if we hit, that's worth 15. 27. We're not printing out the multipliers anymore. I think we may have our logic backwards or our distances backwards. Yes, this is 0. And the notebooks make it harder. Okay. So then, yeah, we need to print out the multipliers, and then I think we just are backwards in our layout. So when we go underscore mark 3 dot move 2. No, I think this is the right order. Mark 1, you have to be at least half the screen away in order for it to count as a point. Which probably means we should move the archer somewhere else. Robert, times 0.75 of the way across. This one times 0.5, 0.25, 0.125. So if we are less than rectangle, if we are less than mark 3, less than. There we go. That should flip the logic around. So when our default starting location should get no points. You have to move away to get points. You have to move a long ways away to get points. Get the most points. Okay. Repudiary. So that's nothing. We have to move out past this line. So let's move to here. That should still be nothing. If we just move a little on this side, now we suddenly get points. Move all the way to here. I should print out the multiplier and the points, huh? Just so I can tell what I'm doing. That should be 1 point. Yeah, we can't actually tell the multiplier very well. We should print it out. Print it out. Note. Points. Multiplier. Just to make sure it makes sense. We can walk around and make sure that it's about what we would expect. Overall, this is looking quite good. Still got some time. But then tomorrow we can start the solar system. More of a space-flavored chop dead. I think in tomorrow we can get the whole solar system done, maybe? That's still a multiplier of 0, so if we walk to here, multiplier of 1, we finally get points. We move close to this guy. Multiplier of 1 still. Unless we move to this side of it. That should be multiplier 2. If we could hit. Four times 2 looks good. Move right there. 2 times 2. Multiplier 3 on this edge. 4 times 3. 3 times 3. Oof, 1 times 3, not very good. All right. Oh, dodged it. know this is possible. Okay, that will never get not old. Perfect. Last piece. Where I set up the mark. Underscore mark dot mark one dot set UV set color 192, 192, 192, and then does this draw on top? Mark one dot render. The mark does render on top of Robert. So maybe change the colors a bit. Orange, yellow, green, or something, or blue, or mark one dot set color. I go with them like an orange, yellow, green. Let me get a color picker. Oh mine, hex color picker, don't care. That orange is not bad. We'll try that one. Okay, now I want a yellow. Yellow? Um, 2, 6, yellow. Oh, no, no, hex. Maybe not that yellow. Something. Dolly? 255, 255, 140. We'll try that. Then we want like a nice blue. Maybe that orange we need to back. Different thing. Actually, we don't want colors that correlate with our game much. But I do want this orange, but maybe a little paler. Oh, no, no, no. Comic tangerine. Sounds legit. Okay, let's try that. Get those colors in, get them tested. Yeah, that's way better to measure the point multiplier based on where you are relative to the mark. That's dead simple. One other thing we need to check. Well, that's not exactly in the order I thought they'd be in. And why is that one white? Oh, because we're overwriting our own value. Shoot. We did this. Mark. Super close. We also need to try this on the small scale setting and make sure that we've done everything we can to be consistent. Our little guy's going to be tiny. No points. One point multiplier. 2-point multiplier. 3-point multiplier, yep. Oof. No points for hitting the target. That's pretty sad. But everything seems to be scaling just fine. And then shooting oneself, always an option. Nope, missed. Missed. Oof. It's trickier than it looks. Oh. Oh, that radius is not right, is it? Head. 12.5 is not being scaled. Look. Head radius equals renderer scale 12.5. I knew we would do this to ourselves, but all right. Okay. My little dude is looking pretty good. All the math is scaled except for the head radius. So this should do the job. Missed. Not bad, not bad. Okay, now we gotta shoot ourselves. Missed. It's not as easy as it. That looked better. Oh, he dies. Okay. I would say that's the dude done. Journal. Target and scoring. Fade in, fade out. All right. Archer now shoots the target. Distance is a factor for scoring. Marked to indicate distance. Let's see what else. 90-point max. Possible. Archer and all the stuff now fades in and out. Boom, done. Make one more animation. Is that what we want to do? Do we want to do one more idle animation? We have half an hour left. we can do an idle animation, which this texture does still have a lot of empty room in it, and it's not small enough that we could reasonably shrink it. So if we add one more animation sequence, we can add a wave, right? We have the entire idle sequence. We can just borrow idle 1. Should we do it? Let's do it. Actually, let's okay, it's not for me. Okay. That is pretty fun. And a fun little archer scoring implemented fade in out working. Okay. Almost done. Almost done. So let's share GIMP. Duplicate. Idle 2. Move this active layer to about here. Delete, delete, delete. Okay. So these are now all idle 2. Uh-oh. Oh well. 2. 2. 2. 2. 2. 2. 2. 1, 2, 3, 4, 5, 6, 7. Okay. 02, 02. 3, 04, 05. Here, I'm gonna do that. 6, 07. Okay, idle 2. Here we go. The bow is not going to move. Just the hand. We're going to start with the same position as the idle. Then we're going to raise the hand. So this guy, we're going to erase a lot of these. So let's make that 8 pixels. I said 8. There we go. Maybe a little smaller. 4. It's not actually erasing that much. There we go. All right, next guy. It's a bit of a trim. So we're going to have him raise his hand and wave at us. And he has to lower it, so we may actually end up with a longer sequence than this, and that's fine. In fact, we may just duplicate this guy. Idle 2. Duplicate layer. Move. Right here. Except that this is 739. We need to go down to 80. So 81.9. 81.9. 1, 2. So 81. 82. 1. There we go. Model 2. We move this active layer there. Okay, we're going to wave the hand for 2 cycles. Oops, see kangaroo. I'm liking the animation progress. Thanks. I'm kind of hoping this is like the end of the most of my animation. I think I'm about animated out for the year. If that makes sense. I'm not. Idle 2A, idle 2B. I just can only do so much animation, I think. 8. I'm a programmer, not an artist, so that's my excuse. But it is pretty fun. 12. There's probably lots of things I could do to make it easier on myself, but I don't know them, so we just wing it. 14, 14, 15, 15. Okay. I think 16 frames for this one is plenty. Okay. Oh. Yeah, it looks like a lot. I was getting so tired of refactoring. Almost done. Oh, good. Yeah, a big refactor can be a lot of work, but it can be so rewarding too. Like, once it's all cleaned up, so much better. Let's see this guy. Okay. So the trick that I found with animating is you just place the hands where they go. 8. So just gonna raise a hand. Come back and erase later. It's gonna go higher, Then above shoulder level. A little higher, and then he's gonna wave out. Center. Back in. Then back towards the center. Out. Center. Back in. And then we got a few frames to drop the hand. So we start lowering it. Maybe there. Down. There. Okay. Now we get the eraser and do the last bits of erasing here. Grab this. 4. 4. Then we'll come back and add the arm in. Easy peasy. Erase. Erase. Okay. Getting close. I don't know how I want to do this on like a timer. Some number of animation cycles. If he sits there idle for long enough, he just waves and then resets the idle count. That doesn't seem like the worst. Okay, now back to hand painting. Painting the arms back in. 8 pixels. I said 8. Okay, this doesn't take long usually. Wasn't great, but that's okay. Fix it in post, right? Isn't that what Hollywood always does? All right, from there to there. The nice thing is, I'm not a professional artist, so nobody is expecting exactly great art out of me. So things are a little bit sloppy. There's no consequences. feel like we need more hand dropping frames. Where are we at? 16? 4 more frames or so. Well, or we just drop the hand faster. Which means and that should re-enter idle 1. Okay, so let's go put that in, and hopefully this is gonna work. Yeah, refactoring is, I don't know if exhausting is the right word, but idle 2, 126, 7. And it's 16 frames. So 127. Good heavens. 127 plus 16. 143, which is 142. 142 frames, more or less. All right. Embed PNGs. Rebuild our image warehouse. We'll have him flip-flop every frame. Minute or 2 on this one. Oh, yeah. Good progress. Archer is going to be done. Yeah, I think solar system tomorrow. Solar system, and the solar system shouldn't be too hard. I think we'll be okay with that one. I don't know. I guess it depends on how crazy I want to go. I could see like comets shooting across the screen. Nebula. Should we put a nebula in the background? That could be kind of fun. Ooh. Okay, then Archer, we need 2 idols. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Idle 1. Idle 1. That's fine. Idle 2. Initialize elements, start in idle 1. That's fine. Handle mouse press. Oh, no. Okay. idle 1 or idle 2, and all that mess. If we're an idle 1 or idle 2, fine. Idle 1. The distance is less than our arrival distance. That goes to idle 1, yeah. Okay, Chalk Archer. We need to idle count. Robert, idle count. State 0. So every time we complete this, if Robert's state is Robert state idle 1, then we do that. If Robert idle count is greater than 5, we'll try it. Then underscore Robert, set Robert's state to state idle 2. Then we reset and start and update. All right, let's try that. So every 5 times through the normal idle, he's going to wave his arm. Of course, after Robert. Okay, no more warnings, so we're good to go. Maybe we speed up the animation a little bit. I don't know. We'll take a look. We'll see how bad it is. Run it. All right, going back to full screen, or big screen. Okay. Three, 4. Then it disappears. And never comes back. Does not come back. So if we're in idle 2, idle 1. Did I not export this thing, or oh well, yeah. Okay, I did not export this thing. Let me export. I think I have to re-embed the data. Oh, good heavens. Okay. We'll try that out. If this idle works, pretty much done with that. We'll do a space one tomorrow. There will be very little state in it. You can do some twinkly stars, that sort of thing. Ooh. So we need 8 planets, some asteroids. We could do quite a few asteroids even. We're just going to use ellipses. In fact, the only tricky piece is computing our z depth. So when things overlap, since our ellipses will be 2-dimensional, we'll have to compute some kind of sinusoidal z depth to go along with it. All right, let's see here. $550. All we want is this to fire off. So 1, 2, 3, 4. Well, he is looping. Oh, I know why. Okay. Fair enough. When we do this, underscore idle count, Robert idle count goes back to 0. We'll wave and then be done. Where are you going to draw the solar system? So we have different chalk things. I'll show you here in a second. Let me test this last wave. There are actually 3 different chalk doodads we've got done now. So for our little dude, 1, 2, 3, 4, 2, 3, 4, 5. Yeah. It's not a very good animation, but it gets it across. Okay. Good enough. So we actually have 3 of them. And then we'll switch between them. So if we go to stores in context, and we say Archer right here, we actually have a ball. Let's compile with the ball as the default. Because part of the idea is every time you load the level, load the game, it picks a random one to start from. Then we're going to implement a piece of chalk and an eraser so you can end the current chalk doodad and draw the next one in the sequence. So let's see what the ball looks like on the chalkboard. So there's no Archer now, it's just this purple ball. And you can pick up and throw the ball. So that's one. We also have bubbles. So just different things. They're all random. Right now they're going all on the chalkboard, and they won't all be on the chalkboard at once, just one at a time. So we got a purple bouncy ball. We got our archer, Robert of Locksley. And we also have bubbles. They'll randomly they'll randomly show up and cycle through as you need to. So there's a bunch of bubbles. And they'll float around and bounce off of each other, which is very nice. You can right click them to pop them. Just like that. So that's it. We've got 3 chalk doodads done now. I'm gonna say Robin should wave less often than he does. So going back to Archer. Idle count. Okay. Greater than, I don't know, 12. We could do, let's see here, Archer. We have global or math. We have math. Doodad chalk Archer. Robert idle count max. Robert idle count max. In elements, we do set state. Set Robert state there. So all we really need then is if we enter idle 1, Robert idle count equals 0. Robert idle count max equals math. Give me the uniform random number generator. Next, in between 12 and 45 seconds. 30 and 45 seconds. Robert idle count idle 2. So this one, the only thing that really matters is that it gets the plus plus at the right place. And there we go. Now we have random numbers of things. Okay, interesting. Archer. I guess we need URNG here. Uniform RNG. Then we'll do the solar system. It'll be in the bottom part of that chalkboard, just like the Archer is. Then I think we'll do a plant one. Nice little like biology plant one. I think I can do the whole solar system tomorrow. Solar systems shouldn't be rocket science compared to what we've got going on with this animation stuff. Okay, so he idles for some number of seconds. He should wave, but not that often. Those arrows, I want them to be more grayed out, I think. The scoreboard too, I think 192 is too light. Is he gonna wave or what? Eventually. looks terrible. That's okay. Alright. Honk. No points. Nil pois. 4 points. Woo. Double points. Oh, too high. There we go. Nice. Walk, little dude. Ah. Okay, cool. So just a couple of small tweaks and we're done. Molt. Okay, that's good. What else do we need? We need underscore scoreboard dot set text color 28, 128, 128. I also want the arrows, I think. Where are my arrows? For each arrow. Arrow .2 set color. Oh. Arrow. Arrow mark. Set color. Which happens when we set UV. And when we set to this, we go full white. 255, 255, 255. Okay. All right, here we go. Last piece, commit, save, done, right? And then we'll never do another animation again, as long as we live. Probably not. At least not this week. Not animations with stick figures, anyway. Everything will be positional and mathematical ellipses. It'll be wonderful. Okay. Those arrows are kind of grayed out. I'm a terrible shot, and it's okay. Okay. I think those grays make it look a little better. Where's my other arrow? Oh, it's in the ceiling. Okay. There we go. We were done. Our archer is serviceable. Boom. All right. Not bad. Done. Save it. Call it good. Journal. Added a second idle animation. That is a wave. I'm not going to do bow. I don't think I'm done. runs a number of idle 1 cycles, then switches to idle 2 after idle 2 is done. It switches back to idle 1. Done. Get status. Get add everything. Added idle 2 animation to Archer. Okay, done. We're done. We're good. All right, ladies and gentlemen, thank you for joining me today. We are going to call it there, and tomorrow we're going to build the solar system. So you have a wonderful evening, and we'll see you then. Bye-bye.